Dear students, today I am going to give an introduction about your subject EST 130. And EST 130 comprises of both basic electrical engineering and basic electronics engineering. And here I am going to say about basic electrical engineering. And before going to the EST 130, you want to know what is electrical engineering. Electrical engineering is an engineering discipline concerned with the study, design and application of equipment, devices and systems which use electricity, electronics and electromagnetism. And also you will be having a question, why learning of basic of electrical engineering required for civil engineering students? You know that as civil engineering, electrical engineering and mechanical engineering, they are all basic branches and they are connected to each other and each engineer has to depend each other. Okay, so if you become a civil engineer, you want to know some basics of electrical engineering while you are doing your design in your home planning or building planning. So you want to have an awareness of basics of electrical engineering in order to apply electrical engineering in your civil applications. So we are learning basics of electrical engineering in your civil engineering branch. So the first module comprises of electric circuits and its analysis. You can see here this is a simple electrical circuit where we can light a bulb using a battery. So when we say about electrical circuit, we have to familiarize with these terms. What is current, what is voltage, what is power, what is resistance. So you know that current is flow of electrons and voltage is the potential difference between the 2 points, and resistance, it is opposition to the flow of current, and power, it is the product of voltage and current, and unit of power is watts. So you will be studying in detail about these terminologies in this module. Then you want to learn Ohm's law. Without Ohm's law, there is no electrical engineering. So Ohm's law says that current, the voltage, the potential difference across 2 points is directly proportional to the current flow through it, and I is equal to V by R. And we have to learn about the connection, series and parallel connection of components or loads in a practical application. When we are connecting the end point of one load to the starting point of another load, then it is said to be series. So this is a series circuit. Here the end point of one is connected to the starting point of R2. This is series circuit. And in parallel connection, we are having the end point and starting point of R2 is connected to the end point and starting point of R1. This type of connection is called parallel connection. So we want to learn about series and parallel connection and how we want to find effective resistance of a series and parallel network in module 1. Then comes the Kirchhoff law. Kirchhoff law, there are two Kirchhoff law, Kirchhoff current law and Kirchhoff voltage law. And Kirchhoff current law states that sum of current meeting at a point is 0, or sum of current entering the node is equal to sum of current leaving a node. And Kirchhoff voltage law states that sum of potential differences in a circuit, that is sigma V1, V2, etc. Vn is equal to 0. So again the heart of this chapter is we will be coming to the analysis, that is mesh analysis and nodal analysis using this Kirchhoff current law and Kirchhoff voltage law in the first module. Also we will be learning star and star delta conversion in the first module. Then comes the second module where deals with magnetic circuits. We know that in a magnetic circuit there will be magnetic flux lines around it, and flux lines, the total number of lines is called flux, and the opposition is called reluctance, and the flux per unit area is called flux density. So we want to study about the analysis, that is we want to study about the analysis of magnetic circuits, that is both series and parallel magnetic circuits in second module. Then comes your then in the second module you also will study about what is the difference between DC and AC. You know that DC is direct current, AC is alternating current. So the difference of DC and AC and how the AC is generated and everything will be learned in this second module. Then you will be familiarizing with different loads R, L, C, resistive load, inductive load and capacitive load connected in an AC circuit, and what will be the power of the circuit also will be studied in this second module. And you will be familiarized with the term active, reactive power and apparent power. What is the difference between active power, reactive power and apparent power? You know that active power, it is a useful power or the power that can be used by the load, and reactive power, that is a power which is lost in reactive components like inductor, capacitor, etc. And apparent power, that is a sum of both active and reactive power. So then in the third module you will be studying about three-phase system. So in three-phase system you can connect in either star connection or delta connection. So the difference between star and delta connection, advantages of three-phase system, everything will be detailed in third module. And we will be studying what is the relationship between voltage and current, phase voltage, line voltage, what is phase voltage, what is line voltage, what is the relationship between phase voltage and line voltage in star connection and delta connection in this third module. So this is all about your introductory section, and you will be having 3 modules for basic electrical engineering for EST 130, where you will be going to learn these things. Thank you.